Aurora Borealis.
In this video, we're focusing about two main questions. What is the history of the discovery of the science behind the Northern Lights and how the Northern Lights are made? Enjoy! Race to space, Hamza Majid, the Aurora Borealis. If you are wondering... Hey, that's my part. Okay, I'm sorry. If you are wondering where the Northern Lights got their name, then I'm happy to tell you that the famous astronomer Galileo Galilei is the one that gave them their name. The Aurora Borealis, which in Latin means dawn of the north. But it wasn't until the Norwegian scientist Christian Birkeland in 1896 that we were able to figure out exactly how this phenomena occurs. Our sun has both a massive gravitational power and an incredible heat that it exists on a fourth state of matter, which is plasma.
Yes, there is a fourth state of matter, and yes, the Northern Lights are mainly caused by the sun.
It's basically ions and electrons floating freely around one another. These particles have a high energy that they can escape the massive gravitational field of the sun. They travel away from the sun at a constant gale of plasma known as the solar wind at a velocity of 750 kilometers per second toward Earth. This plasma can be very harmful to the human body, but luckily the Earth is saved by its magnetic field called the magnetosphere, and the plasma is reflected. However, the Earth's magnetosphere have two weak spots. Those are the poles, the north one and the south one, and the particles can make their way to Earth through these weak spots. And here is where the magic happens. The electrons from the solar wind hit the oxygen and nitrogen atoms that exist 20 to 200 miles above the surface. These electrons give their energy to the oxygen and nitrogen atoms and excite them. And to calm back down, these atoms have to shoot some of their energy in the form of photons. Here's a simulation on how this thing works.
An atom is consisted of a nucleus and electrons floating around it in a lot of concentric orbits. Each orbit represents a state of energy. The further the orbit is from the nucleus, the higher energy it represents. However, electrons can move from their lower orbit to a higher one by absorbing a photon or by being bombarded by another electron. We call that excitation. In fact, these electrons have to come back to their lower orbit. This can be possible by shooting a photon.
And like that, the Aurora Borealis is in our sky.
The aurora can be seen in other planets like Mars, Saturn, and Uranus. Different atoms can create different colors when they are excited. As an example, oxygen gives a green, nitrogen gives a blue or red. The aurora is always going on, but you can't see it in the day because the aurora is much dimmer than the sunlight.
That's it, guys, and see you later.